So students, now let's start the new activity, activity 1.1, types of relations. Our objective for this activity is to verify that the relation R in the set L of all lines in a plane defined by R equals to LM such that L is perpendicular to M is symmetric but neither reflexive nor transitive. So students, now let's start the method of construction for the given activity. First, take a drawing board and fix a graph paper on it. With the help of pins. Take a drawing board and fix a graph paper on it with the help of pins. On graph sheet, draw some straight lines in such a way that some lines are parallel to each other. Some are perpendicular to each other and some are inclined to each other. Name these lines as L1, L2, M1, M2, N1 and N1, N2 as given in figure. So students, now let's see the observation and conclusion for the given activity. First, from the construction, we observe that the line L1 is perpendicular to the line M1. L1 is perpendicular to M1. And M1 is perpendicular to L1. Therefore, we can write L1 M1 belongs to R and M1 L1 belongs to R. Similarly, we can observe that L2 is perpendicular to M2 and M2 is perpendicular to L2. So therefore, the set L2, M2 belongs to R and the set M2, L2 belongs to R. So in the third step, we observe that in the same way, we observe that L1 is perpendicular to M2 and M2 is perpendicular to L1. Therefore, L1 M2 belongs to R and M2 L1 belongs to R. Fourth, also L2 is perpendicular to M1 and M1 is perpendicular to L2. Therefore, L2 M1 belongs to R and M1 L2 belongs to R. From the all observations, we conclude that relation R is symmetric. So hence we conclude from the given observation that the relation R, as mentioned in our observation, is symmetric. Again, so in step 5 again we observe that there is no line perpendicular to itself. Therefore, L1 set does not belongs to R and M1 does not belong to R and N1 does not belong to R. Hence, we can say that the relation R is not reflexive. Now in step 6, again from the construction we observe that M1 is perpendicular to L1 and L1 is perpendicular to M2, but M1 is not perpendicular to M2. Here, M1 is parallel to M2. Here, M1 is parallel to M2. M1, L1 belongs to R and L1 M2 belongs to R but M1 M2 does not belongs to R. But M1 M2 does not belongs to R. Similarly, we observe that L1 is perpendicular to M1 and M1 is perpendicular to L2. But L1 is not perpendicular to L2. Here L1 is parallel to L2. Therefore, L1 M1 belongs to R and M1 L2 belongs to R but L1 L2 does not belongs to R. Hence, relation R is not transitive. Thus, the activity is verified that the relation R in the set L of all lines in a plane defined by R equals to L M such that L is perpendicular to M, is symmetric, but neither reflexive nor transitive. Thus, the activity can be repeated further by drawing some more lines in different positions.